Hello class, this is a video about exercise 3. In this exercise there are 4 questions to compare the means between two populations. The objective between three populations, the objective of this week exercise is to practice ANOVA test and understand this. And briefly, if I want to explain, the ANOVA is comparing three different populations, and by reporting the f value and then converting the f value to the p value to see the p value here. So similar to the other week, there's a table in the class. So the table has a high competitive, moderate competitive, and low competitive market with 4 questions. The question asks you to report information, complete the table, populate the table with number of observation, mean standard deviation, and then finally ANOVA at the last column, and then what's the main significant for the difference, and then you need to go and look at the significant differences. Similar to the other week of the other weeks of the class, the significant differences happened if the p-value is less than 0.05. Any number less than 0.05, any number. So if then there is significant difference. If not, if p-value, let's change like this, if p-value bigger or equal even equal, then there is no significant differences. There is a significant difference. This is the point for this question, and then so you just need to look at this and then report them. Use the density curve and compare hospital cost and revenue between the three markets. Okay, and a student who are working with Excel more likely are not able to see the density plots. So if you are working with Excel, report the bar chart instead. And then what's the impact of being the high competitive market on hospital revenue and cost. And then to do that, you can compare. So you need to compute the hospital net benefit. Again, here, if you are working with Excel, you need to generate this variable. If you already generated for the other weeks, that's fine. You don't need to generate again. You need to look at the net benefit and then compare the means. And it should, let's say, mean 1, mean 2, mean 3. And if this number here is less than 0.05, then you can say at least one of this market is different. Then you need to look at the means and see M1, M2, and M3, and which of them is the higher mean, and then you can report that as an impact of market to the hospital net benefit. Finally, the impact. You also need to compare the impact on Medicare and Medicare discharge. There is 2 ways to do that. The first way is The first way is just compare each market, high competitive market with moderate competitive market, and then low competitive market with a moderate competitive market, and then high competitive market with a low competitive market, three different t-tests. Or you can go with a regression model. RStudio is focused on I think the RStudio focused on the regression model. Let's see what I did here. Okay, did I report regression here? No, I did not report regression model. Okay, let's go and just compare the p-value again here. You don't need to compute the regression model, and then you can just go with t-test. Yes, I follow the t-test here. Okay, now let's go with RStudio. Then after that, I will go and look at this an example. I will give you an example on Excel as well. Okay, this is the file. This is the do file. I mean our script. This is only for week 3, so there is no week 4 here. The week 4 is different. Okay, the way the code has been written is based to report the result on the Excel. To do it, to see the result here, please remove this from this code, and then mute these two lines, so you will see everything here. I always suggest you to just recommend actually to you to read the codes and see what I have done here. For example, here I generated benefit variables, Medicare ratio, Medicaid ratio, and then this is the formula. Even if you have decided to work with Excel, use this formula to compute the net benefit. Should be hospital revenue minus hospital cost for entire data, and the Medicare ratio should be total hospital Medicare discharge divided to total hospital discharges. The same for Medicaid, total hospital Medicaid discharge divided to total hospital discharge. So these are three variables I have generated in RStudio. You don't need to do that, but you need to create actually three variables in Excel. So for RStudio, you just need to make sure that the address is correct, the path actually is correct. This is CUMUC, and if you are working with Mac, it should be something like this. Sync should be tilde, right? Tilde as this tilde. Documents UMUC. I believe this is in the Mac. So the same here for reading this. If you are working with Mac, and this should be this number, you can just copy from here. Document slash tilde slash document slash UMUC, and I believe you already created a UMUC folder in my computer for the Mac. Let's say for Mac, I muted here, so for Mac, just do it in your side. Okay, and this is for Windows. Then I'm gonna go and just select everything, so you can right click here, select all, and click run. Okay, as long as you don't see any error message, everything is fine. Error is density, so never ignore this type of error. This is back to the program issues. So as long as you have this result, all of them here, you are fine. You can go to drive C UMUC and see if the data is correct. I'm going to check mine here, C UMUC, and if I update it, because I have lots of file here, date modify, yes, this is here, 9/2 of September 2nd, 6:28 p.m. and this is the time I'm recording this video. Here the first row is make sure to look at the notes here. Even if you're working with Excel, you need this note. 0 is high competitive, 1 is moderate, and 2 is low. Okay, 0, the point is, even you can just copy this to text file. You can copy here, you can just copy here to make sure you're in the right direction. 0 competitive high, 1 moderate, 2 in the first row is um, mean, and these are standard deviation. So whenever this is none, it does mean this is none. You can just put none, you don't put 0. 0 is different with none. And these are the means, these are the number of observation, and these are ANOVA tests. The ANOVA test here is here, degree of freedom, residual. The degree of freedom I will explain in Excel, it should be k minus 1. K is number of group minus 1, and we have 3 group minus 1, 2, and residual is n minus k, and we have n 3030, and then minus k, k is 3, we have 3027, and this is the f value, and this is the stone p value. So the p value is very close to is very 0. So there is significant differences between hospital beds between 3 markets. Okay, this is an example, and that's it. This is R, and let's go back to R again. So if you like to see everything in console, you just need to mute the sync comment, and okay, also mute sync comment here, right? Otherwise you're gonna receive an error message. And then select everything and run, and you will see everything here. So make sure to compare your numbers with a couple of numbers here, so you will find. So there's actually nothing to report here. There is actually here, but also this is about plots. You can use this key back to see the plots. Okay, the figure 1 is revenue and cost. They are following each other. So this is the first figure. The second figure is about comparing Medicare ratio between 3 different markets. And this is high, Medicaid, and low. Something happened to this. Let's see what's going on. It's figure 2. Figure 2. Okay, figure 2 here. This is figure 2. Yep. Let me run this. Okay, and the reason was because I didn't give enough space to this. You can run again here, or just you can keep as it is and run everything again here. The first of all, you need to give more space to the console, run the code one time, and then give more space to this and run the code again to have a better shape. Okay, here, and this is figure 2, high, moderate, and low. High, moderate, and low. As you see, the high competitive market more likely to have Medicare ratio. Okay, this is figure 3, comparing Medicaid ratio. It was a Medicare. This is Medicaid. This is figure 2. There is outliers here. So and this is cost and revenue. So you can follow that. Cost and revenue between low competitive market. All of them are following each other. So make sure to copy all the plots to your assignments. And this is everything. If you have any problem with a Dippler package, you can run non-Dippler package codes. This is codes with no Dippler package. For this code, everything is the same. Make sure to fix, and then you will see something like this here. So it's almost the same things, but I just copying, just give you and if you go back to exercise 3 is here 634. You see this is here, right? It's reported as a means as the order I run the code. The easy way and to go with no deploy package is just mute the sync and run everything here and see everything in the console. It's much easier to follow. Look at this, you can see all the numbers here and populate your table. This is a step 9. Okay, this is here. Okay, this is now deploy package. Here start from your mean for high competitive markets, and also there is a note in the data set: high competitive markets, a standard deviation, mean standard deviation, moderate mean standard deviation, and low markets. If you look at the codes, this is the mean, this is the data set. So this is a high. The good things about the console, you can see all the notes. You are not able to see all the notes in the text file. Okay, because I already saved this code, I don't need to save it again, but in your side, make sure to save your code. Please make sure to discuss your findings, and then you are good to go. This is an example with ANOVA test in Excel. For the Excel, this is week 3 exercise. You can copy the tables, and then basically the mean standard number of observation mean standard deviation is the same as week 1, right? Because you already have this, and you don't. I don't need to repeat that. The only difference is here is let me go with only one example here. The only difference is you need to find the variable for filtering. The filtering variable is column n. I believe it's column n. Let's see. MN Herfindahl index. Yes, this is Herfindahl index. This is column O. And then this is column O, right? This is 0, and this is column O. Make sure, because I add one more column here in my file. Maybe you are not in the column O. Maybe for you this is it should be different column. Make sure what's the column name. And then H2 is a hospital beds, right? Total hospital bed is here. Color H, yeah, that's it. And then I can see this for the means. You can use average if. This is H, this is color O, right? And this is 0 because this is 0 of what I'm doing here. It should be, sorry, I have to do it here. I feel high competitive market. This is column O, this is column O, and this is 0, right? This is 0. This is column O. This is column O, and this is 0. This is column O. This is column O, and this is the edge for column for the hospital bed, and this is 0, and you know for this you have to hold Ctrl Shift and Enter. You can copy this for this and this, but you need to change that. For example, the color O should be color 1, and but it should be the same edge, right? Because this is still hospital bed. Can go with the same thing here. It should be edge O. Okay, the good thing is O is still fixed, and I think, okay, this is here H26 to H30, okay, H26 H30 55, and okay, the same thing here. This should be 1, and this should be H, right, because it's still the same H. And you can press hold Ctrl Shift and Enter. The same for here. This number should be 1 and the same, everything the same, but only these things should be 2, right? This should be 2 and this should be H. And that's it. But okay, this should be 3 H2 till H3031, right? The same here. H2, okay, it should be H2, not H26. 31, all of them 2, 31, the same here. Oh, should be this one, should be 2, 31, 2, 31. Okay, this is 231 OH, and the filter should be 2, right? The 2 is for low competitive market. This is a H2, right? H2 H31, and this is O, and this is 2. And then you should, okay, that's it. And this is the finally for this one. This is 2, and this is H2 H3031, and I should keep hold. Okay, this is here. You can do the same thing for the other part, but the interesting thing is about the ANOVA test. So let me give you an example. The data set I'm providing is a long data set. You more likely are not able to use the ANOVA t-test in the Excel. If it was a wide data, you could go with Alice data Alice, and choose ANOVA single factor and okay this, and then you should select the range, for example here. So this is a default, this is not correct, just to show how do you want to do that. And this is it, and the output should be here. You can ask to put the output here, right? You can close this and okay, and you can see everything here. But this is not correct because this, the way I'm generating this variable is just as an example. I just showed to you how to do that. I mean, it's not a real data, but that was a way. If it was a long data, it was a wide data, you can easily go with that. If you can convert the data to the wide data, and then you can go with that option. And you know what the difference is between wide data and long data, right? So this, let me give you an example. This is A, B, C. For example, we have 5 observations for everyone, 5, and let's say 6. Let's start with 10, 20, 30, 40, 50. And let's say this is started from 100, 200, 300, 400, 500. So this is a wide data, right? So for the wide data, you can easily go to the data analysis, single. The range of data should be from here till here. Close this. Alpha should be 5%. The output range should put here. We can put here, and then we can close this and press OK. So you can see this result here. We have 3 groups, and it's easy. It's very easy to go, right? We have three group, n minus 1, k minus 1 is 2. We have 10 observation, and then it's very easy to go with that. But the point is, the class data is in form of the long data. This is the y data. So let me remove this. This is the y data, right? For each observation, for each variable, you have one column here. The data set in the class is like this. Right, this is A, this is B, and this is C. Let's say A and B and C is a high competitive market, moderate I say mode, and this is a low. So with this data, you are not able to do this. I mean the ANOVA. Otherwise, if you convert the data to the y, it's very easy to go. Okay, I'm giving you an example how to work with long data. First of all, this is the formula we need to compute, right? We have three populations, so this is an example. So total sum of, so we need to compute on this three value here. When we have this three value, we can compute the f. To compute the f, first of all, we need to compute between groups, within groups, and total. I mean SSB is sum square between group, right? Sum of a square between groups. SSV is SW sum of a square within groups, and SST sum of a square for total. So it's not TSS, it's SST sum square of total. So we need to compute this, and compute this one, and then we need to compute the mean square, and then we need to compute the F ratio. In this example, I'm going to show you how to compute all of this for only one variable, hospital beds. You can, this is the point for Excel users. You can write this formula one time here, right? And then change the variable here. So I will show you how to do that. This is the hospital bed, this is Herfindahl cat, and this Herfindahl cat is from 0 to 1. You are not able to see the 0 here because I just hide the data. If I unhide the data, you can see sum of the Herfindahl cat is 0, right? Something like here. It was here. So the data is not sorted, so it's not important even to sort the data. Anyhow, if it was sorted, it was maybe you could see them easier. So let's say I have, for now I need only two variables: Herfindahl cats, a category of Herfindahl index, and the hospital beds. So first of all, I need to compute the mean for total. The mean total, I like to compute the SST first. Whenever I have one of them, so the SSB is a very long way to go with that. So if I compute SSST and SSV, SSW, so I can easily compute this one. So I'm going to SSST because the data is already in the long data set, so I just can go with and compute the average for entire data set, right? The average is between G2 till G3031 entire data sets. This is the mean, right? And then I also need to compute means. Oh, let's go with this one first, right? This is the means, and I'm going to compute the SST. To compute the SST, I need to go with this formula sigma xi minus x. Actually, I have to compute something like this. I have to say, okay, for example, for the first row, go ahead and do something like this: 376 minus 19, and then report the square root for this on power of 2. For the first number, this is what I need. So you cannot say, let me give exactly the same. I'm gonna give this variable, and if you see that, it should exactly the same number I have here. This is the formula I just have here. The formula is say, okay, fix this, the row, the G 3035, and subtract G2 from this, and given the power of 2. I compare for 1, and then you can select this and do it for all of them. And then you need to summarize, give a sum. The sum should be equal sum from AC2 to AC3031. Then this is for total observation. So we are here. This is here, right? This is here. I have this one here. I'm going to do SSW. The SSW is I have to compute for 3 different markers: high, moderate, and low. So for this, I have a mean here, right? So for this means here, I need to compute the means only for high competitive markets. So we can use equal average ifs, and then it should be G2 till G3031, and the n is a Herfindahl index cat if only if 0. Just it gives me this means for high competitive market for bets. I can do the same thing and filtering with 1, and I can do the same thing with filtering by 2, and then I need to use the same here, so for all the observations. So I'm doing this this value minus this value h, and on power of 2 to make a square root. So right, and then so it actually generates this value, this variable for entire observation. So if I do it here, so you can see it's for entire observation. Then I can summarize only for high competitive market. So I can use a summarize if comment here and summarize only for comment. The same here. I can use this minus this, and it should be, oh, this is the point, and it should be G, right? It should be G2. Why? What I'm doing here? This is G2. Yeah, this is a G2. This is a good discovery. This is a G2, and this is here. Okay, and it should be G. It should be G. The same for G here, and it should be G. And you can do that. So if we actually I filter them by this 1, 2, okay, here, and then this value should be all of these 3 value, this value plus this value plus this. Whenever I have these 2, I can easily compute the between groups, right? I just need to subtract this one from this one, so I have this one here. Then I need to compute the degree of freedom. The degree of freedom is equal to number of population, number of group here, k minus 1. We have 3 groups here, 1, 2, 3, minus 1 should be this one, and I have the total number of observation here, count n minus k. N is for entire data set. I can use count, right? The count for the hospital bed, it should be G2 to G3031 minus number of k, number of groups is, yes, it's 3020. 21. And then I need to compute the MSB. MSD is called SSB divided by K minus 1, this divided by this. And it should be, I can compute the MSV. It should be this value divided this number of observation. This is give me this value, MSW. And then for the F, I can compute this, right? It should be, come on, okay. It should be this, MSB divided by MSW. So MSV, it give me this number. And here, to convert the F to the P value, I can look at this. It should be this value, G305053. This is the F value. G3047 denominator, and this number should be equal to the number of the value they computed by X. I believe it should be computed by this. Let's see if we have the same value here. I believe we had. Let's see, and do I have the same value here? Yes, we have the same value, 20.24. Let's say 24. I'll exact the same number here. If I round this number, you can see this one here is exactly as ours. So this is the point. So you do it one time, right? You do it one time only, and then for the second, for example, you want to go ahead with, and this is okay, this is the value here, right? You have the P value here. You can compute, if you can report this, it should be 0. 4 decimals, this is 0. And okay, you can just add a decimal to the 4. It's very easy to go, right? For the number of paid employees, you just need to go with this. The number of paid employees is here, right? Number of paid employees. Okay. Paid employees, unpaid. This is this number. You can copy this to this. An entire number will be computed automatically. So you don't need to change that, right? Did you get what I did here? And this should be this number. Let me copy entire things from here, even with a label. Copy. Okay. So it's automatically generated every number for you. You just need to do it one time, but make sure to just copy this, because every time it will change. And then let's go with the second number of non-paid employees. The non-paid employees are here. Okay, total number of non-paid employees. Paid, non-paid. You can copy this to this here. A lot of them is missing, because there's, even if you look at the RStudio, we didn't have an entire groups. That's a reason Excel is not able to compute that, because actually basically this is a t-test. So you just need to report that. Even for the RStudio user, you need to report that too. Let's go with the other observation. Let's say with a system member, intern and residence. I'm gonna give, this is the last example for this. Intern and residence is this number. Intern and residence. Okay, this is it. Probably this is the same problem. Okay, no, we have these numbers here. So this is also for intern and residence. And then just one last point to compute the ratio. Do I have a ratio here? So I don't have the data. Medicare ratio. It was something like total Medicare discharge. Let's see which of them is this. Total Medicare, total hospital discharge is this, AB. Total Medicare discharge. Okay, this is it. This number divided by this number. and you can click here and compute for all of them, right? And for the Medicaid, you should go with this. It was this one, right? This was Medicaid. Okay, you can divide this by total hospital discharge, and if you want to compare that, you can copy this from here to this. And again here it is probably most of them is negative or zero. For that reason we are not able to do that. Let's go with a Medicaid. It's not computed. It's computed for Medicaid, it's not computed for Medicare. Okay, this is it for Excel users. And then whenever you have this one, you can just compute. The last one is about you can just do a bar graph, right? Because the bar graph was for hospital benefits, so you can just go here, insert, and just go with bar graph, right? This is it. And then you can add the title here and the label here. You can change the label, don't, or just add a definition for the label. Okay, I'm removing here. And that's it. Or you can just go with this if you like to have a label here. So you can just go with a high mode low, right? The high is this one. This means the low moderate is this one, and the low is this one, right? So if you can go with this, you can see the label here. So this is for this, right? See that this is added chart title here. It should be not for hospital bed, but just this is an example for the hospital. This is hospital beds, right? This is beds. Okay, class, thank you for listening to this live session. Please, not a live session, to the video, please make sure to read the question carefully, answer to all of the question, and then there's also other video in the YouTube for the RStudio users. You can just search zare.rstudio in Google. RStudio, something like this, and you will find other video on that. Okay, thank you and have a great day. This is the end of this video. Let me stop here, and goodbye, class.